In this video, we're going to be going over how to create confidence intervals for our population mean of mu. And to do that, we're going to need a sample mean of x bar, and we're going to need the population standard deviation, or sigma. So to talk about confidence intervals, we're first going to describe what those are. So if we're looking at a normal distribution, which we know from the central limit theorem that our sample means, our x bars, will be normally distributed. If we're looking for, say, a 50% confidence interval, we'll say that goes from here to here, where our x bar is centered in the middle of that distribution. We're trying to figure out the width of that space, so from here to here, where 50% chance that our mean, mu, is within that interval. And that's our confidence interval. And then if we talk about this area on the other side, from here out and from here out, where our error is, we're going to call that alpha. So we have alpha divided by 2 on the far right extreme and alpha divided by 2 on the far left extreme. To find our confidence interval then for our mu value, we first need to set what we want that percentage to be. So for example, we'll set our confidence interval for 95% confidence, which means our alpha is 1 minus 0.95, so it's equal to 0.05. Which means we're going to have alpha divided by 2, or 0.025, error on either end. So to find our confidence interval, we take our x bar value, and we add and subtract, because we have a symmetric distribution, so it's even on either side. Add and subtract our z value, which corresponds to that alpha divided by 2, so 0.025. And then we multiply that by our sigma, for the distribution of our x bar values. So sigma sub x bar. Where if we're just given our population standard deviation turns into, we get x bar plus or minus our z value for our alpha divided by 2, or 0.025, times our population sigma divided by the square root of n, because that's our formula for converting our population sigma back to sigma of our sample means. So to see how this confidence interval stuff works, we're going to start off with a simple example. And for our example, we're going to have a sample size of n equals 100 people, where the average height of those people, or x bar, is equal to 71 inches. And then we know that the population standard deviation is equal to 4 inches. And then, using that information, we're going to try to construct a 95% confidence interval. So first of all, if we're creating a 95% confidence interval, that means our alpha, or our error, is equal to 5%. So we're going to be searching for a z value of alpha over 2, which is equal to z of 0.05 over 2, which is going to equal z of 0.025. Then, to find our confidence interval, we take our x bar value, then we add and subtract our z value. So in this case, our z value is going to turn into, looking up in the z table, we get a 1.960 standard deviation value. So we have plus or minus 1.960 standard deviations. So we have sigma of that x bar. And since we're only given sigma of the population and not sigma of the sample means, we're going to need to convert that. So that's going to turn into x bar plus or minus 1.960 times sigma of our population divided by the square root of n. So that equals x bar plus or minus 1.960 again times sigma, which is 4, divided by square root of n. Since n is 100, square root of n is 10, so we get 4 over 10. And then that turns into, again, we get x bar. We're going to substitute in our 71 now, so we have 71 plus or minus 1.960 times 4 divided by 10, or 0.4. So carrying out that multiplication, we get our 71 plus or minus 1.960 times 0.4, which turns into 0.784. So that means our interval is 71 minus 0.784, so 70.216 up to 71 plus 0.784, so 71.784. And we are then 95% confident that our mu value lies within that range. So mu is within this range up here. So to make sure we understand how to do these confidence intervals, we're going to do one more example. So for our example, we have our sample mean, x bar, is equal to 180 pounds. And then we have our sigma value, our standard deviation for the population, is 10 pounds. And then finally we have our sample size, n, is equal to 25 people. And then we're going to be finding a 90% confidence interval, which turns into alpha is equal to 0.1, which means we're trying to find z of alpha divided by 2. So z of alpha over 2 is equal to z of 0.05. And if we look that up in the z table, z of 0.05, 5% on that right extreme, we're going to get a z value of 1.645 sigmas, our standard deviations away from the mean. So to find that confidence interval, we're going to take our x bar and then add and subtract our z value at 0.05 error and multiply that by our standard deviation for our x bars, which turns into our x bar plus or minus our z of 0.05 times our population standard deviation divided by the square root of n. Then if we plug in all of our different values that we know into that, we get 180 plus or minus our z value of 1.645. Then we multiply that by sigma of 10 divided by the square root of n. Since n is 25, square root of n is 5, so we get 10 over 5, which turns into 180 plus or minus 1.645 times 2. So we get 180 plus or minus, and that turns into 3.290. And that turns into our confidence interval. So we say mu is in the range of 176.710 and 183.290. We are 90% confident of that. So we're 90% confident that mu is within that range of 176.710 and 183.290. Given our sample mean weight is 180, the population standard deviation is 10 pounds, and we have a sample size of 25 people.